A very good morning and good evening to all the participants. Let's welcome to the new webinar by Bharat 6G Alliance, which is a research alliance of academia, startup, industry facilitated by the government. And today we have very important topic, that what are the various features of 3GPP release 18, 19, and what is being done as a study or work item 20, 19, 20, 21. So I am sure that today's this participants, I think we have Professor Radhakant Krishna Ganti as a moderator. Sir is already a Rashtriya Yuva awardee by the government of India for the innovations in 5G. And we have with him Mr. Puneet Jain, who is chair of 3GPP SA, as well as Dr. Anil Kumar from IIT Madras and Dr. Venkat Siva Sai Prasad. So welcome you all, and with this I request my chairman, Professor David Koil Pillai sir, to just set the context which will be followed by Professor Ganti. So thank you all, welcome you all, and namaste.
Thank you very much, Mr. Pathak. I'd like to add a personal word of welcome to all the participants. A quick word about the program today. The 6G Leadership Technical Talks are our flagship event of Bharat 6G Alliance. For those of you who may not be very familiar with Bharat 6G Alliance, just a quick summary. Started in 2023 with the mandate the 6G market and also to prepare the rollout of 6G in India by the year 2030. It's an ecosystem which consists of industry, academia, and R&D members, about 87, who are working across 7 working groups. And in the context of today's talk, the topics that are being discussed are primarily of interest in the technology working group. And one of the mandates of the of Bharat 6G Alliance is to support the sharing of knowledge within the regarding 6G, and that is what we have strongly done over the past few months. So if you look at it, the strategic role is to build the 6G ecosystem, and knowledge sharing is one, and today's event is a significant contributor in that area. Bharat 6G Alliance has also documented a roadmap for India in terms of 6G, looking at how to bring together the various members of the ecosystem to participate in the R&D development within the country in the area of 6G. So if you look at what has happened in the recent past, the last 3 weeks, we've had a talk on fixed wireless access, and by a team from Ericsson. Last week was a topic on the 5G-Advanced from Rode and Schwartz, and today's presentation is going to take it further in terms of understanding what's happening in 6G, looking at releases 19, 20, 21. So this is part of our efforts to share knowledge. Also, we are actively working to build up the ecosystem. So as you can see, we had a couple of trainings on regarding patents and how the entire process, what are the opportunities available within India. So with that, let me say once again, very warm welcome to Mr. Puneet Jain, to Dr. Anil Kumar and Dr. Sai Prasad. Thank you for sharing the knowledge and for presenting today. My colleague, Professor Radhakrishna Ganti, who is a pioneer in the area of the 5G and 6G, will be our moderator. So welcome to Professor Ganti and to the speakers. And now over to Professor Ganti.
Thank you, David. Thank you, David. Thanks for having me here. So I'm very excited for this workshop. We have 3 great speakers lined up. I'll introduce them subsequently, but before that, I want to set a little bit of context on why we are having this kind of workshop, and from there we'll take it forward. Okay? So currently, there's a lot of buzz happening around 6G. Okay, so 5G, there was a lot of buzz, and now there are deployments of 5G happened everywhere. And now researchers, industry people, governments are working towards deploying. I mean, towards getting 6G fruitful and hopefully getting it deployed in the next 5-6 years. Okay, so there's a lot of activity happening or not. So the question is, so this workshop mainly tries to address what exactly is happening in 3GPP, what is it doing, what are the different topics that it's studying. Okay, so if you look at 5G was about high throughput, good latency, IoT, and other kind of services. Okay, so what is 6G doing? 6G is also doing the same thing. Okay, it's doing what 5G is doing and something better also. So it's trying to improve the throughput, of course, which is obvious. It's improving the latency, which is good, and a lot of energy efficiency is also being considered in 6G. But more importantly than that, I mean, all of us have now, in some way or the other, have used AML, LLMs, and other things. So AML is going to become an integral part of 6G. Okay, so this has been decided in ITU. So it's in ITU, one of the KPI is that is AML part of 6G. Okay, which is IMT 2030, the technical name for it. Okay, so AML is going to become a part of this. So I mean, what do you mean by AML becoming a part of 6G? So is it going to be there only in the core network? Is it going to be there in the radio network? Or is the networks going to be designed for better AML performance? What exactly is going to happen? Where is AML going to come into picture? Okay, this is a question that maybe we will get some answers in this workshop. So another important thing that is happening that was not there in 5G is this ISAC. Okay, so if you look at 5G, 5G is how like all these multi-antenna radios, 32 antenna systems, 64 antenna systems. Okay, and mainly the use in 5G for these radios is about data, pushing the data limits, getting higher and higher throughput, serving more users. Okay, but one thing that if you look at these kind of systems can also be used like effectively like radars to identify where an object that is not part of your network is. Of course, if you have an object that's part of your network, you want to localize it. But if something is not part of your network also, you want to find it out. Okay, so this is integrated sensing and communication. Okay, so this is one big area of study that is happening in 6G. Okay. So ITU has defined several KPI for ISAC, and 3GPP is also trying to understand how to integrate out ISAC into the 6G framework. So we are also going to move into exciting new frequencies. Okay, and there's going to be non-terrestrial networks in 6G. Essentially, satellite integration is already started with 5G, but the integration in 6G is going to be much more tighter. Okay. So to even enable all this, some team somewhere has to sit down and look at what is the high level architecture of this entire system. That is what SA does. Okay, so once SA figures out, I mean, how do you put all this huge complex system together? The individual components are, I mean, the radio access component is done by RAM. Okay, so in this workshop, what we are trying to do was this. We are trying to tell people who have not attended 3GPP meetings and ITU meetings what exactly is happening in 6G in 3GPP, specifically in 3GPP. Okay, some of them will of course touch a little bit about ITU also. So what exactly is happening in 3GPP? Okay, just as a brief introduction. So 3GPP currently is doing something called a study item. Okay, so before a spec is written, the technical aspects of the technology are studied. Okay, are studied by multiple companies, and then they come to some high level conclusions on, okay, 6G should have this kind of bandwidth, 6G should have these many antennas, 6G should have AML architecture like this. Okay, that is what study item does. Once the study item is finished, it's followed by a work item in which the spec is written. So where do you put a specific bit? Because the study item feeds into the work item. Okay, so now we're in the phase of study item where a lot of exciting works are happening. I mean, they're trying to push the best things into 6G. Okay, so this is the basic prelude for this workshop. We have a great line of speakers that are there. First, I would like to introduce Mr. Puneet Jain, who is the first speaker. He's currently the chair of SA in 3GPP. he's part of the Intel standards team, and he has been driving research and standardization of end-to-end networks architecture for 5G. He has been very, very instrumental in the essay work in 5G, and now he is doing a lot of work. He's heading the whole 6G essay effort. He's the current. He was previously the 3GPP SA2 chair and the SA2 vice chair. You can understand his experience on looking at this thing. He also was part of the TSDSI family, TSDSI Global SDO Task Force, and also the 1 M2M Steering Committee Vice Chair. So I want to welcome Mr. Puneet Jain. Puneet, the floor is yours. You have about 45 minutes.
Thank you very much, Professor Ganti. I hope everybody can hear me. Hello, everyone, and
Yes.
namaskar. Thank you to the Bharat 6G Alliance for inviting and giving me this opportunity to share an update and progress of 5G Advanced and 6G standardization work within. Today, basically, I will provide an overview of where we stand in 3GPP roadmap towards 6G. I'll also discuss the key 6G study areas currently underway across the SA working groups. And I'll also conclude with a look ahead on Release 21, which will mark the beginning of normative 6G standardization and the path towards IMT 2030. Okay, so with that, let's begin by looking at where we are today with Release 19. So this slide shows the Release 19 timeline, which represents the latest phase of 5G Advanced standardization. So Release 19 progressed through the traditional 3GPP stages, from service requirements to architecture to the protocol specifications, and finally towards the ASN and OpenAPI freezes, which happened in December 2025. So this provides a stable foundation for the industry while also allowing 3GPP to focus increasingly on Release 20 work and transitions towards 6G. As you may all know that Release 19 is now complete and stable across all areas of 3GPP, and this is a significant milestone because it marks the completion of the latest 5G Advanced release and delivers a broad set of new capabilities across radio core network, services, security, and management functions. There is a great summary which is in TR 21919. I have a link over here, which gives you a very good overall summary of all the key features that has been specified as part of Release 19. And I welcome you to basically take a look at this. Then Release 20. Release 20 is introduces an important change on how 3GPP is organizing its work. And here basically the release is structured into two distinct tracks. One is about Release 20 5G Advanced. So we have a continuation of 5G Advanced topics in Release 20. And then it also kind of offers a bridge towards 6G studies. So the 5G tracks continues all the 5G Advanced through both studies and normative, while 6G track focuses on the study activities to define the foundation of future 6G system. And this approach allows 3GPP to continue enhancing 5G while simultaneously preparing for the next generation. This slide shows the timeline for 5G Advanced portion of Release 20. The release follows a 18-month cycle and includes both the studies and normative work across service, architecture, protocols, and radio domain. The key milestones include Stage 2 completion in 2026, Stage 3 completion in March 2027, and ASN and OpenAPI freeze in June of 2027. Another important activity is a dedicated essay workshop that helped define the scope and content of this Release 20 5G Advanced work. And overall, this demonstrates that 5G innovation continues strongly, even as 6G studies are getting underway as part of Release 20. So this slide just gives a snapshot of a progress across the 5G-Advanced work. So I mainly covered the SA working groups. So the SA1, which is stage 1, has been frozen since June 2025. Stage 2, and which is primarily done in SA2 and SA6 working groups, has achieved a 80% completion milestone. And there are significant number of new normative works are now underway. The SA3, SA4, and SA5, which does both the architecture as well as the protocol definition, that is stage 3 work, also has a number of studies which are now 78% overall completion index, and then the normative work is somewhere around 45% complete. Now, moving towards the overall 3GPP 6G work plan, the journey began with the Stage 1 IMT 2030 workshop that was held in Rotterdam in May 2024. This was the first time 3GPP brought together a broad ecosystem of operators, vendors, research alliance, and vertical industries, including Bharat 6G Alliance, to discuss 6G use cases and scenarios. The outcome was comprehensive set of use cases and service expectations that directly fed into SA1 6G requirement study. Then in March 2025, we held a TSG-wide 6G workshop in Incheon, Korea, and it drew a tremendous interest. Over 1,600 people registered and around 750 attending in person. The workshop wasn't meant to produce a formal conclusion, but it pivoted in setting direction. It gave the working groups in SA and RAN a shared foundation for common understanding to guide the technical studies that followed. Then in April 2025, 3GPP and ORAN Alliance held a joint 6G coordination workshop to share high-level perspectives. And 3GPP and ORAN committed to establishing a common understanding of each organization's roles and responsibilities and to support the success of 6G. Together, these workshops shaped the 6G work plan. Former Release 20 study items was approved soon after, covering system and services requirements, architecture, security, and radio aspects. And these studies now form the basis of Release 20 normative work, which will be aligned with IMT 2030 timelines. I'm going to talk a little bit more about the Release 21 timeline in the later slides.
Mr. Puneet, can I interrupt you 1 minute?
Yeah, of course. Go ahead. Sorry, is there a question?
Hello. Yes. Yes. So, one question I have is, I mean, just for the sake of the users, you're using the word normative. Maybe you can just explain it once. A lot of people may not know
Yeah.
what is normative.
Yeah, thank you. I think you briefly explained it. Let me give a little bit more perspective on that one, right? So the way 3GPP works is we did the studies. Studies are basically to understand the key issues, what we call as a problem statements, and also understand the various solutions options to address those key issues. And as part of that study, we have a conclusions, and those conclusions basically form the basis for a normative work. And by normative, what we mean is this is actually the work items from which you basically the normative specifications are specified, and these specifications is the format basically of the commercial products that gets deployed into the network. So it's basically moving from studies to a normative work item, and that's where the specifications are built.
Thank you, Mr. Puneet.
Oops. Okay, so then for basically Release 20 6G study timeline, this is spanning from early 2024 to 2027, and it tracks the SA1 6G studies, SA2 and RAN working group study item definition, and progression into the stage 3 studies. Again, this is may also come another things which is in 3GPP we basically works in 3 stages. Stage 1 is about requirements. Stage 2 is about architecture definition, and the stage 3 is about the protocol definitions. So this is more like a waterfall model that is being followed in 3GPP. Now we are progressing our technical proposals and workshop directly in line with the IMT 2030 technical performance requirements, evaluation criteria, and their submission templates. This guarantees that 3GPP 6G standards will meet all the global regulatory and baseline performance expectations. Okay, so let me now deep dive into some of the studies that are ongoing in the assay working group. The first and foremost is the uh, uh, study on services requirements, which is in assay 1. And I'm also pleased to announce that that the SA1 6G service requirement study is 100% complete. The technical report, which was an output of this study, is 22.870. That was also approved in the March plenary meeting. When we look at the breakdown of contributions, AI and system operations aspects were the most heavily discussed topics, each of them marking up 28% of the study focus. In fact, we identified over 150 potential requirements for each of these two domains alone. This was then followed by integrated sensing and communication at 11%, ubiquitous connectivity at 8%, and industry verticals also at 8%. So this data clearly demonstrate that the industry is pivoting towards creating an intelligent, sensing capable, and operationally robust network architecture. So let's dive into the AI capabilities, which is a massive focus of the discussion during the SA1 study item. So 6G is fundamentally expected to be an AI native system. We are defining network AI agents designed to handle user services intent and providing dynamic combination of 3GPP services to fulfill that intent. The AI use cases include enhanced support of AI applications. It also includes third-party AI agent registration, collaborative features, AI model training, and inferencing. The performance KPIs established to support this is incredibly ambitious. From image Gen AI application, study listed a 50 millisecond burst latency for a 400 kilobyte burst. For video Gen AI, the target is 400 millisecond of a massive 20 burst millisecond. Furthermore, uplink throughput study shows need for a significant increase in requirements and range from 64 to 400 megabytes per second, specifically for Gen AI applications. Also, studies in SA1 shows ability to distinguish between communication latency and compute latency, with a total end-to-end service latency for system like enhanced services robots sitting tightly between 90 and 140 milliseconds. Integrated sensing and communication, or ISAC in short, is set to transform the cellular network into an intelligent distributed sensor. This capability will allow the network to detect, classify, and analyze targets. For instance, differentiating between UAV and bird, or predicting vehicle shapes and sizes on highway. It will also enable direct network optimizations by detecting line of sight blockage in real time. The technical KPIs here are of key importance. 3GPP is targeting a sensing range resolution of 0.2 meters for road digitization and an incredibly fine 0.01 meters or 1 centimeter for gesture recognition. Velocity resolution is targeted at 0.2 meters per second, and for sensing bit positioning, study shows a horizontal and vertical accuracy of 0.1 meters, which will be absolutely critical for advancing structural monitoring and high topology mapping. Ubiquitous is another key area. which ensures that 6G eliminates coverage dead zones entirely, and relying heavily on deep satellites and high altitude platforms or HAPS integration. 3GPP is designing the system to provide always-on broadband for massive IoT devices in both sparse and dense setups. Resiliency is a major theme, with new features like PLMN coordination for disaster scenarios and direct UE-to-E communication over HAPS without requiring any ground routing. The performance target for satellite-based communications are also massive. Study in SA1 shows need of 6 gigabits per second on downlink and 3 gigabits per second on the uplink per airplane, supporting mobility speeds up to 1500 kilometers per hour. Furthermore, 3GPP is targeting a satellite-based positioning accuracy of 1 to 5 meters for UAVs and an independent time synchronization framework that completely decouples the network from GNSS dependencies. To support the next generation of immersive communications, the network will feature deep application network collaboration and multimodal XR communication support. This includes spatial association of XR content with positioning info to ensure safe and context-accurate user interactions. For folks envisioning applications like holographic telepresence in healthcare, the network must deliver up to 1 gigabit per second user experience downlink paired with 99.999% reliability. And for split rendering in gaming and remote educations, end-to-end latency must drop below 10 milliseconds. The SA1 studies introduced a brand new KPI called synchronization. This defines a maximum time offset between different media streams, and we are targeting an astonishingly precise 1 to 10 microseconds for immersive audio producing during live events. For massive communication, 6G will deliver essentially wide area coverage and support for low complexity IoT devices. We are aiming for uplink and downlink targets of 5 to 7 megabits per second, handling payload up to 20 megabytes with 100 millisecond latency. For localized networks in industry verticals, factories or disaster zones will be able to maintain full local routing, authentication, and voice functionalities, even if the backhaul is completely severed. The SA1 study again shows the need for an extreme reliability of 99.999% within 1 millisecond latencies to support decentralized power grids and industrial robotics. To support digital twins, we need a 10 centimeter location accuracy and 1 to 10 millisecond latency. Furthermore, the time synchronization accuracy for critical communication in smart grids will be tightened to 1 microseconds over a 20 by 30 kilometer service area. So a network is only as strong as its core operational foundation. And in 6G, system operation aspects were inherit robust 5G functionality while excluding legacy requirements like EUTRAN, UTRAN, and GRAN. Security and privacy are receiving major upgrades, most notably the mandate of quantum-resistant authentication and enhanced threat resilience. For those tracking sustainability and ESG targets, you would be pleased to know that the energy efficiency is a fundamental requirement. 3GPP is also establishing flexible charging framework, data collection enhancements, and resiliency measures for service continuity and degradation mitigation during disasters. So this was practically what I covered was the key KPIs emerging from the 6G SA1 studies on service requirements and the use cases. Now moving to the study on 6G system architecture. This study is ongoing in SA2 and the output is being documented in TR 23.800-01. The study has identified 24 key issues covering both enhancements to core network functions and new 6G capabilities. These include areas such as QoS and policy control, as well as emerging topics like AI integration, integrated sensing, and computing support. A key principle is that a 5G architecture is being used as a foundation for 6G evolution, rather than starting with a completely new architecture. At the same time, the study assumes a native support of both terrestrial and non-terrestrial networks, reflecting a broader connectivity vision for 6G. It is currently evaluating multiple solution options for topics such as voice services, emergency fallbacks, location services, and AI agent coordination. While good progress has been made, several areas are still under study and require close coordination with RAN and other working groups. The architecture study is expected to be complete by March 2027 and will provide a foundation to the normative work that will follow in Release 21. So now moving towards the study on 6G security aspects, and this is primarily happening within SA3 working group, and the output is captured in TR 33.801-01. This study is organized around 7 major security areas. They are covering topics ranging from security architecture and RAN security to network exposure, roaming, authentication, and security monitoring. The work is currently focused on identifying the key security challenges that a future 6G system will face. This includes defining trust anchors, security domains, and 6G key hierarchy, and how security context should be handled when a user moves within the 6G network or between 5G and 6G system. Important activity is the development of preliminary attack models to better understand potential threats and vulnerabilities in the future 6G architecture. Overall, the goal is to ensure that security is built into the 6G system from the start rather than being added on later. Now moving to the 6G study on media aspects. This is ongoing in SA4 and is documented in TR 26.870. The objective is to identify media-related opportunities and gap for 6G while ensuring that the media are reflected in the evolving 6G system architecture. The study covers several topics, including media delivery architecture, emerging media technologies, ubiquitous access, and trusted and private media communications. It is closely coordinated with ongoing in SA1, SA2, RAN, and SA3 to align with the broader 6G developments such as AI sensing, computing, data handling, and QoS. At this stage, the work is focused on identifying gaps and opportunities and determining whether additional studies or future normative work may be needed to support advanced media services in 6G. And this is another study that is ongoing in SA5 on the management and orchestration and documented in TR 32.801-0. The goal is to evolve the current 3GPP management framework towards a highly autonomous, intelligent, and interoperable management system for 6G. The study has already established several high-level architecture principles, including service-based management, cloud-native design, multi-vendor interoperability, and support for operations across multiple domains and administrative boundaries. The number of key features areas are also being investigated, which includes data management, AI and autonomous agents, network digital twin, intent-driven management, and energy efficiency. The work is currently focused on refining these concepts and identifying enhancements that could become part of future 6G management specification. These slides cover the SA6 study on 6G application enablement, which is documented in TR 23.801-02. The study examines how exposure frameworks and application layer enablers can help application and vertical industries fully leverage 6G capabilities. The work has identified key issues across several domains, which include AI and machine learning, communication services, computing capabilities, sensing digital twins, and service exposures. The objective is to understand what new application enablement capabilities may be needed beyond those already available in 5G today. The study has also analyzed a broad set of use cases from both industry verticals and 3GPP service requirements coming from SA1. These findings will help guide future alignments across working groups and lay the foundation for a potential normative work in 6G application enablement in upcoming releases. So this slides gives you a consolidated view of the major 6G studies currently underway across 3GPP working groups. So it includes also the RAN studies that is going on at the working group and plenary level, also the CT groups. Please note there are several studies that was approved in CT 1, 3, and 4 working groups that are not listed here but was approved and will be, but you can find all the details in the 3GPP work plan. And if you want to go through the details of the objective of these studies, then you can go through this column, which is says work item description, WID in short, and each of these hyperlinks will give you a detail of the scope of this work, the timelines, the rapporteurs names, and cross working group dependencies. Now, looking at the 6G normative the work timeline, so this is release 21. So up to this point, the focus has been on 6G studies, and the release 21 marks a transition from study work to the first normative phase of 6G standardization when the 6G specifications will be defined. So release 21 is expected to deliver the first set of 3GPP technical specifications and will form the basis of 3GPP's IMT 2030 submission activities. It was agreed recently at the TSG 112 meeting that happened 2 weeks back. And it targets stage 1 completion in March of 2027 and stage 2 completion in June 2028 and stage 3 completion in December 2028. The ASN and Open API freeze is expected to happen in March 2029. The one thing to be noted is from release 21, 5G Advanced and 6G has a common timeline. So again, the door for 5G Advanced is not closed. So if there are projects for 5G Advanced in release 21, they can be discussed and approved as per the normal 3GPP procedure. So release 21 will be a release where the key 6G architecture, protocols, and procedures are standardized and transformed from the study concept into a deployable specification. So very quickly to conclude, and to summarize, 3GPP is pursuing a dual track approach in release 20, continuing 5G Advanced evolution while simultaneously launching the first comprehensive set of 6G studies. The SA1 requirement studies has already been completed, and the remaining working groups are making solid progress on architecture, security, media management charging, and application enablement aspects. Now looking ahead, release 21 will be a major milestone as it starts normative 6G standardization and prepare the foundation for an IMT 2030 submission. In short, 3GPP has moved from defining the 6G vision to studying the technology and now is on clear path towards first complete set of 6G specifications. This concludes my presentation. Thank you very much for listening. So back to you, Professor Ganti.
Thank you, Puneet. Can you hear me?
Yes, I can hear you.
Okay. I think there's one raised hand. We'll just try to answer him. Mr. Raghav Bhatia, can you type your question or can you speak up? Okay. I think there's one question that Mr. Priyatosh Mandal has posed. How QoS framework of 6G is different from 5G? Puneet.
So QS framework is still being studied. As part of SA2. So again, this is ongoing study, and there is no conclusion on how it will be different. There are several solution variants that is defined in this TR, which I mentioned early on. Let me go back to that one. Okay, I cannot move the slides anymore, but if you go back to the slide on architecture study, then there is a details in the 23801-01, and that is basically going to provide you details on various solution variants for the QoS, right? But again, this is ongoing study, and there is no so far there are no conclusions on the QoS, for 6G. So this is a key issue number 5, what you see on the screen here, right?
Fine. Okay. So he's also asking that say one more question. Briefly explain 6G architecture, please. I think that's a very generic question. We'll come back to that later. So there is one other question from Mr. Vinay. This is something I also have. I'll add to this. Can we participate in 3GPP working group meetings online? Okay, if yes, can we realistically make an impact you just using the TDoc submissions and other things?
Thank you, and this is a really very good question. I think 3GPP actually relies on the face-to-face meetings, and we do have a one-way remote access enabled, for the folks who are not able to participate for any reasons. But I can tell you that most of the decisions are made during the offline discussions, and through the offline discussions and drafting sessions, most of the work progresses in 3GPP. So it is really important to participate in face-to-face meetings, and your influence will be quite limited through the remote participation, because remote participation is we tried to do that during the COVID times, but with that large number of topics and with that large number of delegates that participates in this meeting,
Yes.
it is really impossible to basically run the meeting efficiently, allowing hybrid kind of operations.
I totally
However,
agree with you, Puneet.
yes,
Yeah.
and
Please go ahead.
one thing I want to also just mention that, due to some travel restrictions or the visa issues, we have looked into the scenarios where we do allow two-way remote access. Like, for example, what happened in the Malta meeting, because of Indian delegates could not fly due to the war scenario, and then also visa issues in China meeting. So we did allow two-way remote access, but again, completely relying on remote participation would not be very effective in terms of making an influence and your contribution reached, because there is a very limited time for online presentation. Most of the discussion happens during coffee breaks, lunch breaks, evening dinner discussion and things, and that is really, really important to basically participate, during the face-to-face meetings.
We have few more questions. I think we have 10 more minutes time. I hope we can take some few more questions. So other question is from Prakash C. Dot. So one of the things that happened was 5G was very, very complicated. Okay, both in terms of spec as well as in architectures. So has some concrete steps been taken to simplify the architecture for 6G? So that more people can pitch in into the hardware, software stacks, as well as the whole community can grow.
Yeah, thank you. And this is also a very good question. I mean, so 5G, I understand. I mean, it's been complex. It has a lot of, I mean, and somehow some of them has not been deployed. This is the learning which we are taking as part of 6G studies and the specification work. One thing which we have kind of endorsed as a principle, guiding principle, is that the options, you know, makes the system complex and also the deployments complex. So if there are, we should try to minimize the options and only define multiple options if they are really necessary, you know. And this is one of the guiding principle that has been endorsed and a part of work planning. And as we are discussing the studies, this will be becoming our guiding principles to ensure that we minimize the options moving forward in 6G, which
Yeah,
we
that
hope
would be
to
awesome.
basically going to reduce the complex and also deployments pain points that we see today. You know.
That's really great. So we have one question from Mr. Srinath from Leka. I mean, this is something that maybe interests others also. So his question is it still possible to contribute IPR convertible to SCPs if one starts at the normative phase, release 21? Or we should start now?
Can you repeat the question? I mean, I'm not
So he
able to
says that is
see.
it possible to contribute IPR and convert them to standardization patents if one starts at the normative phase? Okay, I know this is a little bit look ahead,
I
but
mean, I would not want to guide you on any of the IPR. I think you need to contact your legal counsel for that one. You know.
no. So his question is different, Punit. He's saying that the question he's asking is, if someone wants to get their ideas into 3GPP, should they start at
Mhm.
normative stage or study stage? I think that is the question he wants to pose.
I mean, you should start as early as possible, right? I mean, basically, the thing is basically have if you want to contribute towards solving key issues, right, or providing a solutions to key issues, then study is the starting point, right? So because most of the conclusions are done at the study item phase, right? So for example, like let's take in this slide, right? So I mean, QS framework, like again, somebody asked this question before, right? I mean, right now what we have been discussing in SA2 is multiple solution options for the key issues listed under the QS framework. And this is the time to contribute, because at some point of time there will be a conclusions for these key issues, and once the conclusion is done, then the normative phase is very limited in terms of what the, because the solution is already decided, right? So now what you have to specify in terms of protocols aspects and the finer details of that solution, right? So again, so you will be limited in terms of basically contribution, but again, you know, a contribution in a lot of things basically also been decided at the normative phase, because sometimes studies leave them open to be discussed at during the normative phase. So, but again, my recommendation is to start earlier
Yeah.
and you know, not wait for the normative phase.
So one more question, generally this is regarding AI generally. So has agentic AI and semantic communication been looked upon by 6GSA?
Semantic communication and what else you said?
Agentic AI,
Yeah, so
agentic.
I mean, AI is a big focus, right? I mean, agentic AI, as I mentioned earlier, you know, some of the use cases, right? So, what you see, I'm scrolling through the slides. So here you can see basically, you know, this is part of the service requirement studies, right? Now, in terms of also core network design, the in SA2 is looking into the several solution variants. You know, the one solution variant is looking where you can evolve the existing 5G core network architecture and basically kind of overlay a AI domain on top of that over a user plane. So basically, you kind of build an architecture similar to IMS today, where the intent from a user can be passed over a user plane. But then there are other solution variants which are also looking at a new communication mechanism using an agentic protocols, either MCP, A2A, where these what we call as an agentic AI or tools functionality is very tightly integrated with the existing network functions from 5G core. So this is more like an approach which is called as a revolutionary approach for 6G core network architecture. And then there are also various other variants which are currently being discussed. So yes, so in short, basically agentic and AI in general is discussed throughout all the working groups in 3GPP.
I have one question since we are talking about AI. So one of the main problems with AI is I mean, to train any model, you require a lot of data. So how is 3GPP treating fairness? Okay, so early until now, 5G networks, everyone, I mean, at least if you're technically competent, you can sit down and build a 5G network, at least to a certain extent. But with this AI coming in, specifically AI being integrated at the core level, at the RAN level, it has, as I say, looked upon the fairness of the system in such that I mean, how can people develop these models without data? I mean, and data is limited to few people.
Yeah, so that is a very good question. I mean, one thing which was discussed in the plenary, you know, in Singapore was, I mean, and this was in context of what we call as ULBC codec, which is ultra low bit codec, and this is a work I on in SA4, right? And you know, as part of this work, because it may be actually using AI models or the training data sets to basically train these, so train this AI model, which will be part of this AI based codec. Now, one thing which we have been looking is like, and this is something which we have not dealt with is the issue of 3GPP involvement and the legal requirements related to data set needed to train the AI model specific to 3GPP work. And currently, there is a lack of clarity on how 3GPP should handle the legal and procedural requirements for these training data sets. And this is one of the things which I will be escalating to PCG. And since, as you know, that 3GPP is not a legal entity per se, but it is the OPs basically, and it rely on the at-sea legal to provide these things. So what we are looking for, basically investigating, are there specific guidelines to be involved in defining, standardizing, hosting, and validating data sets used to train AI models, specifically for 3GPP work, which I means basically the specifications that are either referencing another AI, basically the AI may have to build within 3GPP, for example, for this ULBC work in SA4. And then the second part of that, it would be, what are the legal frameworks or the requirement that 3GPP should establish for these training data sets. So this is something which we have to start investigating, and we do not have a good answer right now. Yeah.
So, a couple of more questions. You have 5 minutes, so I'm going to utilize your time efficiently. So, there are a bunch of questions on some specific technologies like fixed wireless access, private networks, RIS, reflective intelligent surfaces, IRS, or intelligent reflective surfaces, and quantum. So, which of this actually do you think is important for SA, and is there going to be focus on any of these things? FWA, private networks, RIS, and quantum.
Yeah, so IRIS is something which has been a RAN topic. So for others, are definitely part of the scope of SA. So the private network will be discussed. I mean, again, it is we haven't discussed whether it's going to be a day one feature, day zero feature or not. Fixed wireless access, definitely there is a strong support behind that, and also that is being discussed within SA2. And then quantum, basically post-quantum cryptography is being discussed within SA3. And
Okay.
what they are looking at is also at 5G, because 5G systems are currently being deployed, and that they are at least at the immediate risk of due to these post-quantum crypto threats. And that's what their study is. Their study has been concluded, and then they're gonna look at the 5G aspects first, and then in future they will look at the 6G as well.
Fantastic. So essentially, 3GPP is looking at all of this. It looks like, except the risk is
Yes.
more of a RAN thing than SA at this point, at least. Okay. So one question that there's posting on this thing, and I also want to ask you is: so there are a lot of companies in India who want to participate. Okay, SA, RAN, and everything, but I want to focus on SA. So the question is, at this point, I mean, of course, there are very deep studies, and there are studies which are starting, and things which are easy for newcomers. So, what do you think are the good starting points for new companies or new startups to come and engage with 3GPP in this SA field, in this in the SA vertical?
Yeah, so thank you for this question. So I think the key thing is to basically participate as early as possible. I mean, 3GPP has a complex process, right? And it is by design in some way, right? I mean, because there are many study item. I mean, I covered like at least 6 study item, but then there are multiple, much more like in CT groups and also in RAN groups that are ongoing. And each of these studies, as I pointed, like even if you look at the scope of SA2 study, if I go back on that, has 24 key issues to basically uh, look into. So in order to just to understand, right, the sheer scope of these studies and where you want to participate, what are the your interest, I mean, it takes a while to basically understand. And then there are
Mhm.
procedural aspects, in terms of how do you write a contribution, how do you basically discuss those contribution, and there is a these procedural aspects that you can only get familiar once you are start to participate in this meeting. So my recommendation again is basically participates. I know basically travel is requires a travel, and then it may not come easy for the companies which will have a limited resources. But again, I think what I have been seeing for quite some time is there is a quite increased participation from India. I mean, a lot of delegates I have see them face to face. So, and I think this momentum should continue basically.
So with this note, thank you, Mr. Puneet. It's been a wonderful talk and great Q&A. Really happy that you accepted and was able to give this talk here. Thank you once again.
Thanks a
Okay,
lot. Thanks for the
thank
opportunity.
you.
Yeah,
Have a good day. Bye.
thank you. Bye.
Uh, uh, so okay, Asta, can you move to the next one, please? Oh, sorry, I got the access. So, Mr. Puneet has introduced us to the world of SA, which looks at architectures, core network, and other things, and related areas, security and related areas. Now we'll move into the world of RAN, the radio part of things. A lot of people are interested in this, I know, in India. So there are two people. There are two people who are going to present this. I'm going to introduce both of them, and they're going to talk about what is happening in the world of radios in 3GPP. What is happening in a little bit. They're also going to touch a little bit of ITU, and what are the topics that they're covering, and they'll also be happy to answer a lot of questions. So first, let me introduce Dr. Anil Kumar Errapragada. Dr. Anil is actually a postdoc with me at IIT Madras. He has worked on 5G testbed, and he has been participating regularly in both ITU and 3GPP from the last 3 years. Several he has gone through the entire cycle of ITU evaluation document, KPI document, and contributed significantly to that, and regular participation to 3GPP, and does a lot of several contributions in AIML and RAN related stuff. His expertise is in AIML, and he's basically a wireless communication engineer. His thesis was he got his PhD from University of Texas at San Antonio, where he worked on low latency physical layer security algorithms and SDRs. Okay, I'll also introduce the next speaker. Also, both of them are going to give this talk together. I don't want to disturb them in Redmond. The next speaker is Dr. Venkat Shivasai Prasad, whom we call Sai. He's now a lead engineer at Tejas Networks, and he's actively involved in 3GPP RAN and 3GPP RAN. He was also participating in ITU for a significant amount of time. He actively worked in 5G testbed. He had experience in developing modules in actual 5G base stations. He holds a PhD from Department of Electrical Engineering, IIT Madras. He was a controls person who moved to communication and now contributing significantly to 3GPP. Welcome, both of you. Anil and Sai, the floor is yours. You have time from up to 12:25. Asta, can you please move to their slides? Dr. Anil and Dr. Sai, please, you can go ahead.
Yes. Can everybody hear me?
Yes, yes, it is audible.
All right. Thank you, and thank you very much, Professor, for the introduction. So I am Anil, and along with my colleague from Tejas Networks, Sai. So both of us will present on the progress of 6G studies that are happening in on the RAN side, and we also want to highlight a lot of the Indian contributions that have been presented in these meetings, because in the last couple of years, I think there has been a very good increase in the number of contributions from India, of course, with the support of government and the support of the DOT and MeitY and people like that. So I think it's very appropriate to also highlight what India has been doing. So just to set the stage, I think most of us who have worked with 5G are probably familiar with the use cases that were defined there, the EMBB, MMTC, and the URLLC. So the one of the key differences now as we move towards 6G, based on what has been agreed in the ITU, is that the three use cases in 5G will continue to be there. They've just been renamed as immersive communication, massive communication, and the ultra in URLLC has now become hyper reliable low latency. And in addition to that, I think, as it was mentioned in the in the previous talk and also in the introduction, we now have these three additional use cases that 6G is expected to support, which is the ISAC, the AI, and ubiquitous connectivity. And just in terms of in terms of the timeline, so obviously with 5G, I think the focus was mainly on your broadband services on your cell phones, and then we also heard about these industrial IoT use cases. Then we moved towards these wearable devices, XR devices, drones and apps and that kind of thing. Now we are very much in the era of AI and sensing. So just to give a context to where we are headed. So what I want to do is I just want to spend a couple of minutes explaining what happened in 5G Advanced. And given that 5G Advanced is more or less completed, I won't spend too much time on it. But I just want to explain because a lot of what is happening in 6G takes its roots from some of the 5G Advanced releases. So I'll just very briefly explain what is happening. So 5G Advanced started release 18, and there are some remnants of 5G Advanced still going on in release 20 right now. But the key thing that happened in 5G Advanced is this was the first time AI/ML in the RAN was very seriously considered. So there were study items in release 18, followed by the full specifications were also written in release 19, and the final efforts are now being completed right now in release 20. So positioning, especially the indoor positioning, there was so we found that when you have these indoor factory environments with a lot of clutter, these conventional time and angle based measurements for positioning were not very accurate. So there was a huge study in Release 18 where multiple companies developed these neural networks to do positioning based on measurements from multiple access points, and we found that AIML is pretty good, especially in these non-line of sight scenarios. And then, with respect to another interesting use case that was there, these channel state information, right? So as you increase your number of antennas, and as you the amount of channel estimates that you have to feed back on the uplink, so this becomes a pretty big overhead. So and this overhead increases obviously as you increase your antennas. If you want to report these estimates at a much higher granularity, that also contributes to the overhead. So we found that there was a study which looked at applying AIML to compress these channel matrices, and this is essentially used these two-sided autoencoder models which have an encoder which compresses the channel state, and then a decoder at the other end which reconstructs it. Of course, I'm simplifying things, but essentially these are two-sided models which are, in some sense, they have to be jointly trained, but then they are deployed separately. So this resulted in a lot of issues with the inter-vendor compatibility, because the UE vendor and the network vendor are obviously different. They are essentially different companies, right? So they have their own proprietary issues. So how do you share models? How do you share data? How do you actually get this compatibility? So this was a huge part of the study, and a huge learning experience actually for AIML in 6G, which we will talk about. And then there are other use cases on beam management, and then in addition to the use cases, there was also an effort to have the general framework for AIML, where what kind of signaling is required to support these models. And then in addition to AIML, there was also an effort in Release 19 to have these new backscatter type of devices. How do you integrate them also into the 3GPP ecosystem? Essentially, these are like your RFID, like your FASTag devices, right? Where they rely on backscatter. Maybe you want to do inventory of factories or inventory of other equipment or something. So how do you integrate signaling to these kind of devices? So that was also a major part of the study. And then the usual suspects that are there in every release and every study. MIMO, we're always interested in enhancing the multi-antenna technologies. How do you design reference signals to deal with these larger MIMO arrays? And then coverage, of course, is very, very important. The focus mainly was on coverage in the initial access, the initial signaling required to set up your connection. And then there are also other topics like NTN, which continued from 5G. And then they also did channel modeling for the FR3 band, and some initial efforts on sensing started in 5G-Advanced. And I also want to point out that Indian companies were very, very active, right? So when I say Indian companies, it's just a generic term which I use, but these are mainly Indian, academic institutions, R&D. So most of the IITs, so the CIVIT, Tejas Networks, a lot of the Indian entities were part of 5G-Advanced contributions. And now that more or less the 5G-Advanced specification efforts are done, so now 3GPP is firmly focused on the 6G design. Now, before we get into the design, I think it's important to set some context on how this design is actually structured. And I just want to take a slight detour away from 3GPP, and I want to explain how the ITU comes in, how the ITU influences the 6G design. Essentially the way to think about it is the ITU kind of sets the exam, and 3GPP or any other proponent will come up with the technologies or the answers to the exam, right? So ITU calls it, they have slightly different terminology. So 6G is called IMT 2030. And what ITU worked on over the last couple of years is establishing the KPIs, or as they call it, minimum technical performance requirements. So the minimum KPIs that you have to satisfy if you want to call yourself 6G technology, right? So I'm just taking a snapshot here, summarizing a few things. And I also want to point out that with the support of the Indian government through the NSG 5 and other working groups, India had a very strong influence in ITU through the government delegations, and I think a lot of members from IIT Madras, CIVIT, Tejas, and HFCL, we were part of the delegations. We contributed to shaping some of these KPIs, and so what I want to showcase in this particular slide is that the usual KPIs like data rates, they are there. Some increments are expected, and with respect to the fifth percentile and average spectral efficiency, uh, I think so. There is an effort to increment this by 3x compared to what was there in the 5G of IMT 2020. And here, an interesting thing that I want to highlight is, so the 3x is expected for these smaller cells, right? Mostly found in these urban areas or the western definition of a rural area, which usually include smaller cells. And one of India's contributions is to have a slightly different target specified for, because we want to support larger cell scenarios which have slightly lower mobility and slightly different user density characteristics compared to what the typical western definition of rural areas is. So this is something that so now we have two separate targets, one for smaller cells, one for larger cells. So this was a big achievement from India. And then the other KPIs such as reliability and latency, connection density, these are mostly carried forward from 5G because they are pretty aggressive to begin with. And let's talk about some of the new KPIs, right? So I think, as it has been mentioned today several times, so AI, one of the flagship use cases. So AI for network and network for AI. So I think a lot of the things that were talked about in the essay presentation is about how does your network support the transfer of AI data, right? If you want to, because now we are all interacting with these LLMs and we're using these external AI applications. So how does the network, what kind of data rates and latency is required for the network to support AI? And then the other thing is AI for network, which is what I think my colleague will talk about in a few minutes, is on the actual radio interface. How do you use AI to improve your signaling and improve your communication performance? And then another flagship use case, of course, is the sensing, where now ITU has requirements on detection and false alarm probability and localization of these passive objects, and also tracking of the movement of these objects. So this is slightly different from positioning, because I think positioning, where you assume that you're trying to localize something which has a radio, and in ISAC you're trying to localize passive objects. There's another interesting requirement brought through the industry mainly to support XR use cases is, can you quantify the number of users which jointly satisfy certain requirements? And finally, I just want to mention about a KPI called the link distance. Again, this was very aggressively and very rigorously pushed by, I think, Indian entities in ITU, because we want the technology to be, we want to evaluate the capability of a technology to support specific services. Because when you talk about things like coverage, most of the effort is generally to achieve basic connection, whether you do a voice call or whether you can connect to the network, and whether can you do basic services like voice calls. But what we want to do in India is we want to enable services like digital payments and at least a two-way video call. So can your technology support such services? So of course there is no requirement to do so, but there is a requirement to evaluate your technology and evaluate your specification against the capability to support certain services. So with these ITU requirements as guidance, so now 3GPP is slowly shaping up the 6G elements, especially on the RAN side. So I just want to touch upon a few of those. So the 6G study, so right now release 20 is ongoing, where there's a study item on the 6G radio. This was approved in I guess June of last year, and the very first meeting of the study was in August 2025. So it was actually a pretty proud moment for India, because the first 6G meeting happened in India. It happened in Bangalore in August of last year, and that's where the first efforts actually began there. And I think some of these points are probably covered before. So the idea is to have a simplified approach towards developing the 6G network, reuse as much as you can from 5G, and some key performance targets are, I think, energy efficiency is something that's important. Of course, improved data rates and spectral efficiencies, they are always KPIs. And then coverage is something that is focus, that is of prime focus here. The idea is that now that we have this FR3 band at 7 gigahertz, the idea is to, and for 5G we have a bunch of these mid 3.5 gigahertz sites already deployed. So can you reuse the same sites at 7 gigahertz? So of course there is a there are coverage gap issues with doing that. So the study is looking at how to address those coverage gaps, and we want to support larger channel bandwidths, especially around the 7 gigahertz range. And then the 60 study is divided across 4 working groups in 3GPP. So RAN1, which mostly focuses on the physical layer, where they're looking at the waveform, the frame structure, these channel coding, MIMO antennas, spectrum related issues. So all the physical layer aspects are in RAN1. Protocol issues, L2 software, these radio resource signaling, handovers, those are happening in the RAN2, which mainly looks at L2 signaling. And then the other 2 working groups are RAN3 and RAN4. So RAN3 looks at the interfaces between the RAN and the core. It also looks at interfaces between base stations, right? The XN interface. So why these are important is because if you want to do something like positioning, the actual positioning service, the entity lives in the core network. So, but the measurements are taken in the RAN. So how so because the signal power measurements and so on, they are all taken in the RAN, but the actual service is provided through the core. So the RAN and core interface, what kind of signaling is required there? So that is standardized in RAN3, and RAN4 obviously does a lot of the RF aspects, and a lot of topics, they start their life in RAN1 and they end up in RAN4, because that's where the actual conformance, the actual deployment of the receiver design to achieve the solutions in RAN1, that's where they are looked at. And a few general principles, I think. So we want to do multi-rate spectrum sharing, which is kind of at this point kind of similar to what was already there in 5G, the dynamic spectrum sharing. Study is of course ongoing. And then AI, ML, and sensing, and how do you integrate it with communications. So these are the general objectives of the 6G study, with which the RAN working groups are operating right now. So I'll just maybe get into a few of the details, and then my colleague can continue. So with respect to the waveform, I think this was agreed in pretty much the very first meeting. So there is not much suspense anymore. So we're going to use the same waveform as that was used in 5G, which is OFDM. Your CP OFDM for the downlink, and also the uplink, and then the DFT spread OFDM also in the uplink. And the extra things that are being studied right now is enhancements on top of OFDM, is how do you deal with peak to average power ratio reduction with respect to these OFDM waveforms. So especially the uplink, we have this issue where you're limited by the linear region of your power amplifier. So how far can you push this, right? So if you reduce, so right now the effort in RAN1 is to purely by signal processing techniques. Can you reduce the PAPR of these DFT spread OFDM, and also they're looking at supporting higher layer or rank 2 DFT spread OFDM. And of course, dynamic waveform switching. Most of these are already there in 5G. There is nothing really special happening right now. Most of these are happening in 5G. The PAPR reduction is maybe something that's new. I think again, a lot of Indian companies have contributed to these simulations to support the use of the signal processing techniques for PAPR reduction. And then on the waveform for sensing, again, still based on OFDM, but the targets are slightly different. So obviously, for sensing, you're trying to detect these passive objects. So you're trying to figure, a lot of delay estimations and Doppler estimations, which are so the focus here is on reference signal design, which have good interference resilience and good correlation properties. So nothing is finalized yet. The study is ongoing. Bunch of waveforms are on the table, and the idea is to simulate all of these in the next few meetings, and then a decision will be taken. And of course, this is not just sensing on its own. This is integrated sensing and communication. So, what kind of overheads do these sensing related signals have? So that is also something that has to be studied. And the frame structure and duplexing, again, a lot of things are reused from 5G. I think this time there is an additional emphasis on studying the dynamic TDD. So essentially, your TDD structures are they can either be specified in a static manner and then they never change, or they can be sort of a semi-static approach where through periodic RRC signaling you can change your uplink or downlink pattern, or you can have a very open approach where it's dynamically done. Of course, there are issues with interference across different cells, so those are being studied right now. Sub-band full duplexing, again, we carry forward what we studied in the previous release 18 and 19. Even here, I think there are a lot of Indian contributions. So I can, I think I just hand over to my colleague Sai to explain a few more things, and then I'll come back to conclude.
Sure. Thanks, Anil. Thanks, Professor RK, for introduction. Hi, myself Sai Prasad. I'm working in Tejas as a lead engineer. I worked prior to that. I worked with Anil and Professor RK in the 5G test bed, and we collaborated on the all RAN1, particularly for the past 3 years. So, so this is cell search synchronization signal block, which you might have known. It consists of 20 BRBs in frequency allocation and 4 symbols. So SSB mainly consists of 3 things. One is PSS, SSS, and the PBCH. So both the PSS and SSS are used for acquiring the physical cell IDs, and PBCH decoding helps to get the MIB master information. So the main enhancements are under study in RAN1, are they're considering multiple repetitions of the same beams within a burst, and the number of more number of SSB burst, similar to what is there in 5G NR, but only thing is that beam repetition within a burst is possible now. It's still under study. Once they see a good consensus on the merits, benefits, then they would agree it as a possible option. With respect to the frequency allocation, the RAN1 recommends the with 15 kilohertz subcarrier spacing, it has to be greater than 3 megahertz. In 5G, it was 20 PRBs. Now they are looking at slightly reducing, but the limitation is it has to be greater than 3 megahertz. And in time domain, the early release of 5G NR, it was 4 symbols. 4 symbols. Now, in later releases, that is release 18 or so, particularly in the frequency domain, the puncturing was allowed to accommodate SSB reception by low-end devices, which supports bandwidth of 3 megahertz. Now, a lot of companies contributed with their proposals asking for increase in temporal allocation, which is more than 4. Some people recommended 6, 7, and so. So now the agreement is that there are two options basically. Within the two options, the first option is continue the same 4 symbols, and the second is a maximum of 7 symbols. So third symbol is second option is can we support maximum of 7 symbols. So with that, so still the PSS and SS are used for recovering SLID, same as in 5CNR, and SSB also can be used for mobility related measurements. So the same is continued here. The RSRP computation from SSS is still supported in 6G as well. So this is so now this is initial access from the UV side. So upon reception of the SSB, the user equipment would do a transmission first random access. So there are 64 preambles in 5CNR. So multiple formats are there. Fundamentally, two different formats: long format and short format, which is in the frequency domain. So the fundamental is that these sequences are Jadov2 sequences, which helps on which works on the correlation principle. So now even in so the kind of proposals by companies. So even in 5G, later version of 5G, there are these preamble groups are divided into two groups, Group A and Group B, mainly to support to avoid the contention between two different kinds of UVs. For example, low power UV and low data related UVs are given a particular set of preambles. Other UVs are given another set of preambles. There are some proposals to the RAN1 3GPP that can we further split these preambles such that device specific random access can be enabled. So that is one possible direction. And so the design of preambles also right now it's a Kazakh signal ZF2 sequence. Can we do any enhancements to optimize PAPR, and can we also increase message 3, which is considered as a bottleneck channel because mainly it doesn't have repetitions. So the enhancements to the current random access channel is mainly on the number of preambles and the number of device-specific preamble selections and the design of preambles itself. Moving on to the next one, channel bandwidth. I think we know that in 5G the maximum channel bandwidth of a single carrier is 100 megahertz. So natural extension was many companies proposed 200 megahertz at least to be supported in the initial 6G study. So there was later it also should align with the spectrum availability auctions and how much maximum bandwidth continuous bandwidth operators or these companies can get. But there was a lot of prolonged discussions there were, and in the last RAN meeting, which is in March, it was decided that let's not preclude the option of supporting 400 megahertz in the starting of the 6G study itself. So given that it's an early study, let's not. So in many countries, 200 megahertz is being supported. Availability of 200 megahertz spectrum is the reality, but in few countries where 400 megahertz is available, the option should not be precluded. Hence, it was agreed that we support on the downlink 400 megahertz if EV supports any EV supports 400 megahertz, or we can support how to support 400 downlink if the EV has only 200 megahertz. bandwidth. So these are the options that are currently being discussed at RAN1. That's on the max channel bandwidth, and on the other side is that what is the maximum, what is the bandwidth that we should consider for low tide devices. So it was agreed that 20 megahertz for both the baseband and RF is agreed for the study. Only for off duplex FTD, the baseband bandwidth 5 megahertz. That's the exception. So theoretically, the shaping gain. So because of uniform QAM symbols, there is 1.53 dB gap between the Shannon capacity. So there are a lot of proposals that we can use latest. This constellation shaping is being used in in broadcast and Wi-Fi, and why don't we use these techniques to further enhance the spectrum efficiency uh, in cellular as well. So that's the motivation. So there are two different techniques to make uniform to Gaussian like. One is geometric shaping, where the constellations locations can be changed to align with the Gaussian distribution, or probabilistic shaping, where the constellation points are fixed as a same as a uniform QAM, but the probability of occurrence of these constellation points will follow Gaussian distribution, and it prefers the constellation points which has a lower energy. So this also very a controversial discussion at RAN1. Some people supporting, few people supporting probabilistic shaping, and majority of them being supporting neither of them. And in RAN1 study, there was a long 154-page observations of these evaluations and AWGN and fading channels. However, there is still one more quarter, one more RAN meeting to conclude whether we need constellation shaping or not. Mainly to evaluate them in terms of how much gain we achieve and with what complexity. So with regard to higher order modulation, as you know that 5G supports 256 QAM MCS tables. Now, so on the uplink, the studies on supporting 1024 QAM, mainly intended for FWA type of devices, and on the downlink 4K QAM. So Tejas has submitted significant simulation results on the geometric shaping. Yeah, channel coding is also one of the enhancements that RAN1 delegates thought that we can enhance for 6G data rates. Mainly, the peak data rates for 5G is I think 20 gigahertz, if I'm not wrong, and for 6G it is agreed to be 30 gigabits per second. That's theoretical peak data rate. However, the actual data rates would be different. But however, uh, to obtain higher data rates, what kind of enhancements we do in channel coding? That's the motivation. So a lot of it is that the base graph 1 and base graph 2 of 5G NR is still used for all the data rates in the range of 5G NR. So you know that base graph 1 is for higher data, and base graph 2 is for lower data. So this base graph 1 supports a mother code rate of 1 by 3, and base graph 2 supports a mother code rate of 1 by 5. Now base graph 3 is designed and it is expected, so the expected mother code rate will be greater than 1 by 2. That's what is the agreement. It should support greater than 1 by 2, roughly approximately 2 by 3. So one of the changes to the base graph 3 with respect to base graph 1 is that earlier, so in base graph 1 there are 22 information systematic columns are there, information base. Now and the lifting size was 384. It's just one of the options that people will study. So this is also under study based on the consensus of on the evaluations, whether we support or not will be decided. So on the control data, predominantly polar codes for larger data bits is supported, same as 5 CNR, and for few bits controlled information, read molar codes are still supported in 6G. On the control channel, mainly on the PDCCH, current 5G uses blind decoding to decode PDCCH. Now there are companies proposals from a lot of companies, even including Indian companies, CVIT in particular, asking for two-stage DCI, where first stage DCI is blind decoded, which will have information on the second stage DCI. So the reason for this two-stage DCI is that over time the DCI become more complex in terms of number of aggregation levels, number of formats, and then the payloads. Uh, so to avoid the EV complexity and energy consumption, a two-stage DCI has been proposed. This is two-stage DCI is under study at RAN1. So okay, coverage at 3GPP is an internal KPI. So earlier 5G we don't have something on from the ITU. There is nothing like coverage as a KPI. However, 5G itself coverage was defined as an internal KPI to the 3GPP. With respect to that KPI, we want to evaluate what is the link budget if we have to reuse the 3.5 gigahertz mid-band cells with 7 gigahertz. That's the what range I can get with 7 gigahertz carrier frequency. So we are studying at RAN1 the link budget we considered is path, MPL, maximum path loss, which includes all the antenna gains and all. Whereas coverage as a KPI, maximum coupling loss is used. Maximum coupling loss is just the transmitter power and the receiver sensitivity. So for 5G, the target was 143 dB. This is mainly for the basic coverage. The maximum coupling loss is 143 dB, supporting one downlink 1 Mbps with two UV antennas. The same things, whatever the KPI requirement for 5G for coverage was there in 5G is still agreed for the same in 6G, even with the increase in the carrier frequency. So that has been agreed in a recent June meeting. And also extended coverage, mainly with the loss of data rates, and can we so with the 10 dB loss, can the 6G support a data rate of some few kbps on the downlink and uplink, even with 153 dB loss. So that's called extended coverage. Coming to AML, actually the AML, as Anil mentioned, started release 18 with the three use cases. Three use cases being beam management, CSA feedback enhancements, and positioning. I'll just touch upon why. So is it just a buzz thing that AML is there in the other domains? In 5G, in cellular networks also we need AML. Is it a buzz thing, or is it really, is there a real need for AML in wireless cellular? So one of the things is that with increasing number of higher frequencies and antenna sizes. So for example, beam management in the FR2 range, okay, has to, even SSB has 64 beams. To actually to measure the 64 beams and then report, okay, it would take the sweeping would take a lot of time, and then a lot of energy consumption. So that is one of the motivations where we can we use AML and do lesser number of measurements and still can we predict the best beam. So that's one thing. Regarding CSI also, CSI feedback, there are two aspects to it. One is it has report size is one thing, and the number of and the periodicity of the CSA report is also another thing. So report will have the overhead of the report depends on the granularity and the antenna elements, whereas the report periodicity depends on the channel conditions itself. So one is autoencoder, the other is a temporal prediction kind of a thing. So CSA prediction is a temporal. So I don't have to get the CSA report every, let's say, 60 milliseconds or 120 milliseconds. If AI can be used so that the CSA reporting frequency can I increase. That's the one thing. So that are the 5G advanced use cases. Building on those use cases, the high priority use cases are resource reference signal resource overhead reduction. Basically, can I use a lesser number of reference signals and still estimate a better channel? So that's the case within CSIRS and with DMRS. Actually, with the DMRS, the earlier release of 5G supports maximum of with a single symbol. If I'm not wrong, it will be 2 to 6 and double symbol 12 DMRS ports. 12 DMRS ports, but later releases of 5G supports 24 DMRS ports. Now they want to enhance it to further 48 ports. So these are all the proposals by multiple companies, but the blue highlighted things are being taken for study. Uh, yeah. So the main idea is that in reference signal resource overhead reduction is that I will send minimum number of reference signals and estimate the channel as good as possible. So that's the thing. So with DMRS, actually, there is one more concept called superimposed pilots, where and so reference signals are normally put at particular one of the OFDM symbols, one or few OFDM symbols, and estimate the channel and do interpolation both in frequency and time domain to get the complete channel. Whereas this is the superimposed pilots, where each RE is a combination of both data and pilots. So that is also being studied and proposed and is in the study scope. Okay, with respect to CSI RS, actually, it started release 18. CSI feedback enhancements has two things. As I said, the CSI prediction has been agreed and release 19 into normative phase, but CSI feedback went to a second phase of study in release 19. Even in release 19, only part of it has been agreed as a normative phase, where they doesn't take temporal aspects into consideration. So CSI feedback, CSI compression is the first two-sided model use case, where we have models at both UV and network should work in tandem for CSI compression. So that brings the interoperability issue. So some companies proposed two directions. Direction A and direction C is called. Direction C is where we standardize everything. And then the interoperability question is gone. So in that, going in that direction, some companies proposed this third option, which is there is no encoder, AML encoder, but I do some kind of projection into lower dimension, where the network can provide projection matrix to the respective UVs, and at the network we have, which has more resources capability, can reconstruct the channel. So this is the case. Whereas a two-sided model case, where in order to so in order to avoid any quantization loss or something like that, these two joint source and channel coding has been proposed. These two applications are mainly to address constellation modulation, quantization loss. Yeah, so that's the thing. And yeah, so the CSI channel can be of two types. I can feedback the channel either in eigenvector domain or the explicit channel itself, and depending on the choice of the model, whether it JSCM, JSCM, or the one-sided or projection matrix, the model output at network will change. So for all the CSA related AML models, the generalized cosine similarity has been one of the intermediate KPI, and NMSC, normalized mean square is also one of the KPIs. So how do we evaluate the performance of AML model? The benchmark is E-type 2, enhanced type 2, which is MU-MIMO codebook, which is more granular in terms of frequency domain subbands, and it also has some kind of compression where they use IFFT to convert spatial domain into delay domain. So inherently there is compression in E-type 2. So AML models should perform at least with E-type 2, where there is some a compression without AML. Yeah, so far we have discussed RAN1 AML use cases. This is one use case where RAN4 is involved. I think it's under study at RAN4. So there are mainly two ways of doing the PA nonlinearity. One is digital pre-distortion and post-distortion. Since post-distortion helps AML model at network, I think they prioritized post-distortion study, where uh, after equalization they convert into temporal domain, and AML model is expected to undo the nonlinearity, PA nonlinearity cost. So yeah, with that I think I'll give it back to Anil to continue his presentation.
Yeah, thanks, Sai. So I'll just take maybe 5 to 7 minutes to just address a few more issues, and then we can close up the presentation. So apart from AIML, we also have the ISAC, of course, where the idea is to detect, localize, and also track the movement of passive objects. Of course, this has several use cases where this is where this is applicable. And the study again has just started. How do you integrate with the communication? I think that is one of the key aspects. What kind of reference signals do you use? Right now, the study, of course, supports all the three modes: monostatic, bistatic, and multistatic. So depending on where you are capturing the reflection, or whether you are capturing the reflection from multiple locations, or capturing the location at multiple receivers. So all the methods are open. So this is if anybody is interested in sensing, this is actually a very good time to contribute, because the study is in the very initial stage. Uh, Most of the aspects are open. So as I said, mainly right now the initial use case that is being studied is tracking of UAVs and humans, and there is an effort to build an evaluation framework where you have to agree on the sensing modes, you have to agree on the frequencies, waveform, what kind of antennas you use, and of course the metrics, which are they are defined by the ITU. So obviously the spec has to prove that it supports these particular metrics. Uh, Again, waveform design, and then one thing that was just agreed, I think, in the last meeting is that we would also, I think, at least from the RAN1 point of view, there will be some effort to look at sensing assisted communication. Do now what do you do? What do you use sensing for? For channel estimation or link adaptation or whatever. So that is not agreed yet. But it is agreed that some form of sensing assisted communication will be studied. Again, the exact use cases are open, and I think this is one place where India has actively contributed, even in the ITU, in setting the requirements, and we hope to contribute obviously in the study as well. uh, I think we already mentioned some of the other aspects like energy efficiency. ITU requires that you have to support these higher sleep ratios and sleep durations. And one thing that is a general area that people are looking at is these signals which are always transmitting, like the synchronization signals. Do you really need 20 millisecond periodicity? Is there a way to improve the periodicity? And then of course the two-stage DCI, which was mentioned earlier, reducing the number of blind decoding that is done. So there's a general focus on energy efficiency across multiple use cases. Mobility is another thing which I want to mention, because I think the ITU requires that, as when you're switching between cells, you want your handover latency to be as, or your interruption, at least from an application point of view, there should be no interruption in the use of the application. So this is of course this is evaluated at multiple speeds, both from all the way from your vehicular all the way to high speed train scenarios. And this is a primary activity that's happening in RAN 2, that is the higher layer impact. Um, because most of the commands that dictate the UE or the base station to that a cell switch is happening, they are higher layer signals. So how do you do this as lightweight as possible? Can you reduce the number of measurements required by the UE? Because in some sense you can, in some cases you can predict where a UE is moving. So do you really need to measure all the cells around it, kind of thing? AIML can be used here. And then of course the primary goal is zero interruption, as close to zero interruption as possible, and at least there should be no degradation in the throughput. So this is something that's being studied, and I won't spend too much time on this, but there is also an effort in other working groups to optimize the L2 software, and to look at the RRC modeling, so the states in which the devices are in, right? So these active state, idle state, inactive state. So which state the UE or the device is in, and transition from one state to the other impacts the energy consumption of the UE, because in certain states, the context with respect to the network is completely deleted. In some states, the context is retained. So is there a way to optimize how these state transitions are done? So these are some areas which are being dealt with in the other working groups. Of course, the study has just started, so again, these are areas to contribute. There is not much decision. There is not many decisions that have been taken, so there is still a scope to contribute. And a couple of things. Of course, we mentioned this before. Broadband is of course a priority, but we also there is a significant push from operators that we want to support fixed wireless access, and of course the IoT devices. And now that we have looked at all the spec, right? Or I mean, not the entire spec. We have just picked a few areas of interest. Once the spec is sort of developed, right, or as the spec is being developed, as different technologies are being studied and developed, the idea is that you still need to evaluate those technologies in by simulation in various scenarios. So what 3GPP has agreed is a list of 14 deployment scenarios of interest. So multiple technologies, whether it is AIML or whether it is sensing or any other MIMO improvements, control channel changes, initial access changes, all of them will be simulated on a system level or link level in these different deployment scenarios, where you get the moment you bring in a deployment scenario, you can now specify your antenna configurations, carrier frequencies, and user distributions. So all of those can be simulated. Of course, the ITU doesn't mandate you to support all 14 scenarios. This is a 3GPP requirement. ITU has only about 4 or 5. but 3GPP has agreed on all 14. Here, one big achievement from the Indian members is the inclusion of the single cell for large coverage. So this was a joint effort across multiple meetings where we members from IIT Madras, Tejas, Civit, IIT Kanpur, we worked together to incorporate this particular usage deployment scenario. And the idea is that this will enable you to measure link performance in rural scenarios which are similar to what we find in India, because in India what we have is these clustered deployment of or clustered location of villages, right? Where and then you might have a base station at a gram panchayat, and you're serving these clusters, and the of course for a coverage target your your frequency will be at a much lower frequency, and our mobility is also different, and we want to evaluate for some basic services that we are interested in, like digital payments and so on. So having this as a scenario is very helpful now, because any other technology that is developed in RAN 1, we can, for Indian members and other members who are interested, we can simulate the performance in the single cell scenario as well. So that's the idea. And this is why. So lastly, I just want to end by saying that the upcoming months or the next couple of years, there is a huge scope for Indian participation, because Rel-20 study is ongoing. We already have very good momentum, even as Puneet mentioned, right? We have greater than 200 contributions submitted by Indian organizations every quarter right now, and the higher we can bring that, and the higher the higher participation that we have, the more that we can influence things in 3GPP. A lot of decisions on waveform and channel coding have already been done, but there are several open areas on initial access, AI/ML, sensing. This is a good 6 to 8 months of study still to go, and then of course you have the entire specification effort that will begin from 2021. And the whole point of the first release, or not the whole point, but one of the points of the first release of 6G is that 3GPP has to demonstrate that their Rel-21 spec meets the ITU KPIs. So there will be a separate work item in 3GPP where, as the technologies get finalized, people will do simulations, and they will demonstrate that they can meet the ITU requirements. So this is a huge parallel effort that will also begin. In addition to writing the spec, the simulations towards ITU will also begin. And there is also some areas in which I think we can still get involved with the ITU, even though the TPRs and the evaluation methodologies are finalized. But proponents can submit candidate technologies from a 2-year period from 27 to 29. So 3GPP is one of the proponents. Obviously, India had a technology that was submitted during the 5G time. So the Indian members, we can always contribute through 3GPP if we are members, or if there happens to be an effort from India to do something like last time, we can also contribute through that. And the evaluation of technologies also is something that I think Indian entities can participate by becoming part of these evaluation efforts, where we would then evaluate other proponents' ability to meet the ITU requirements. So just to finish up, I think the study is on 6G is on track, but there is still scope to contribute on a lot of key areas like AI/ML and sensing and so on. And there are ways to get involved with the ITU process as the technology gets finalized around 2030. So the next 2-3 years, I think there is still significant scope for members to get involved. And with that, I think I'll close the presentation, and happy to take some questions.
Thanks, Anil and Sai. Wonderful, comprehensive coverage of what is happening in 3GPP and ITU. There are a few questions. Let me first take the questions that are there in the group. I have answered a few, but there's some things that I don't know. So I'm going to ask you those, and then I will ask a few questions of my own. So one of the questions that Srinath from Lekha is asking is, can you give an example of an IMD 2030 requirement like link distance mapping to any specific study items in the 6G study?
Sure, yeah. Yes. Actually, I saw this question, so I wanted to answer this. So essentially, the link distance ultimately is reported to ITU using a using a link budget table. So with respect to the now parameters in the link budget table, all are influenced by 3GPP study item agreements. So you have, of course, the frequency band that you're going to use, the antennas that you are allowed to use. So these are all the whether you want to what kind of transmit powers to support, what and the ultimately one parameter in the link budget table is the SNR for a particular blur or something, right? So now how high can you push that SNR? That depends on your waveform. It depends on your modulation. It depends on your coding. So all of those are directly drawn from 3GPP study items, and finally you report it to a link budget. But a lot of the parameters are externally drawn from these studies, such as waveform and modulation and antennas, and whether you support FWA, because then you can use a higher antenna height and so on. So it's a combination of multiple aspects which eventually contribute to the link distance.
So there is one more question I want to ask you about AML. So you have talked a lot about how AML can be used to improve the RAN performance. I mean, there are several use cases that you have shown. But what about the other way? How can 6G help AIML? Is 3GPP RAN looking at it, or some other group is looking at it?
So this was, I think Puneet touched upon it a little bit. So there are, in order to support these external use cases like interaction with LLMs and so on, SA has certain I think data rate targets which I think he has projected,
Okay.
and so the RAN is not actively looking at it, but I think it will filter through at some stage, where when they do the spectral efficiency and data rate calculations, the idea is that at least uh, you would have to support some level of AML traffic.
Okay, got it. So one question. You have started attending 3GPP as academics. I mean, from IIT, both of you. So I mean, in India also there are a lot of startups who want to contribute to 3GPP. There are startups, universities, companies, I mean, small companies who want to contribute. So, can you give a perspective on how difficult is it? What is the main things that are required to contribute? Oh, that's one question. The second question is this procedural issues. I don't want to elaborate on that, but what can be done to reduce these procedural issues? I mean, how should they even go ahead and contribute?
Right. So uh, the I think one way to just contribute as quickly as possible is to collaborate with existing members. Now, just to start things, and then to actually influence agreements and to actually ensure that an individual entity's technology is captured accurately in the spec. I think participation in the meetings seems to be required, and it is to some extent it is this is a kind of gatekeeping that is done. And so now attending the meetings, I think becoming members through TSDSI is something that is probably required or will be helpful to contribute. And because the a lot of the agreements in 3GPP are I think, or some of the agreements in 3GPP, they are I guess dependent upon commercial need, because ultimately these are vendors and operators which have to sell this technology, right? So one of the things that often gets pointed out is, if anybody, whenever somebody brings a new technology, is there a commercial need? So all of this requires support. So having companies as members in 3GPP and being there to support things is one way to really push
Got it.
our technology into the agreements. Yeah.
So one thing, just for the for a lot of participants, I think TSDSI is the way to participate in 3GPP. TSDSI does a lot of outreach in terms of TSDSI in B6GA is also doing a lot of outreach on how you contribute to standards and what is the procedural issues and other things. In addition, I'm pretty sure that the current speakers Anil and Sai would be happy to help you out if you have any particular questions regarding the procedural issues or how do you get started on this. Okay, so there's one question that I want to ask from Mr. Kishore. what about this RIS? Everyone in India, a lot of research is happening in RIS, IRS. Is RAN1 looking at RIS or intelligent reflective surfaces?
From a 60 point of view, I think maybe Sai can correct me, but I don't think there is an effort in the current 60 study. The Of course, I think DSDSI has study items and work items that they are doing on RIS, but I don't think there is an active focus in the 3GPP 60 study
Right now. Okay.
right
Got it.
now. Yeah, so maybe in a future release we could potentially get some support and try to bring it into 3GPP, but it's not a day one requirement. Let me put it that way.
What about quantum technology? Quantum technologies, I'm assuming, is not being discussed in RAN1, in RAN at least.
Right, that's right. Yeah.
Okay, fine. Uh, so another question from C dot. This is the last question. After that, I think we have to conclude. AI is increasingly being introduced into the RAN. How does 3GPP balance AI model flexibility with interoperability, considering that the vendors may use proprietary AI models while maintaining standardized interfaces?
Yes, so I think this is a very excellent question. I think maybe I can say something, and I'm sure Sai will have something to add. So when we did the use case on CSI compression, right? So this is a classic case of the two-sided model that had to be done, where you needed an encoder deployed on the UE and a decoder deployed on the network. But in order to deploy them, you had to jointly train the entire model. So now the question is, does obviously a UE vendor doing a joint training is not just going to give away the decoder to the network vendor. So there were in the specification effort there were significant I guess hooks that were added into the spec to facilitate such kind of thing, where maybe you don't share your model directly, but maybe you share some kind of a data set. Maybe let's say you train your autoencoder at one end, and then you share a data set that can then be used by the other side to train the decoder, or maybe you don't, or maybe you share a general sort of architecture which can then be fine tuned by the other end. So sharing of data sets, sharing of model parameters, maybe, or are there ways to have a format in which you can it's like all these binary file formats where you don't know what the architecture is, but you can still use them. So the spec supports the sharing of certain information required to train both sides of the model. So this is just one example.
Got it.
If Sai has anything to add, he can add.
Got it. I think okay. I want to thank you. I mean, for your wonderful presentation. I'll take this a few minutes to conclude. I mean, I don't know how to thank. Generally, we clap, but I'm clapping virtually. So thank you, Anil and Sai. So just I want to take a few minutes to conclude this session, this webinar. So essentially, there's a lot of work going on in 3GPP to standardize 6G right now. Okay, we're in the preliminary phase, technically preliminary phase, the study item, where the relevant technologies are being studied to understand their efficiency, whether they are applicable to the communication systems, what are the use cases, do they make sense financially to the operators. So a lot of studies happening. And I think this is a great opportunity for a lot of companies in India, startups and other things, to come together, collaborate, and push their ideas into this 3GPP ecosystem. Okay, while it may sound daunting, it may look daunting initially. I think it's just a question of getting used to the whole procedures and attending the meetings and talking to other people. I'm pretty sure that Bharat 6G Alliance would be a good anchor. Bharat 6G Alliance and TSSI would be good anchors to help you out if you really want to contribute. There is a good ecosystem in India, and a lot of us will be happy and willing to work with all of you to ensure that there are significant contributions from India, and we have a significant say in 6G. So with that, I would like to conclude. Thank you all for participating. It has been a wonderful webinar. I learned a lot, and I hope all of you also had a similar experience. Thank you.
Professor, if I may say one sentence.
Yes, please. I don't know who it is, but yes, please.
Sai.
Okay, Sai. Yes, please.
Yeah, that the AML thing, interoperability, and also majority of the use cases will be one-sided. I mean, just to the audience who are concerned about this AML interoperability. So, majority of the AML deployments will be one-sided. That is, either they sit on the network side or they sit on the UV side. So it's only enabling, disabling. There is no interoperability question there. But so for two-sided models where there is interaction needed for inference operation between network and UV, there we need interoperability. There, the interoperability is a question. There, some techniques like known model structure. You train a model with known model structure and transfer weights, data transfer prior to the model inference can happen. So that is so there are multiple directions with which two-sided model, how to tackle interoperability with respect to two-sided model is being studied. Hopefully by release 20, there is a current work item on CSI which has a study item or work item on interoperability training. People can look at the agreements there. We'll have some idea about that. Thank you.
Thank you, Sai. Thank you. So, thank you, everyone. The floor is all yours, Asta. We can conclude.
Thank you, Professor Ganti, and to our speakers today for such a wonderful 3GPP roadmap provided for 6G. We got a lot of interest and questions from the participants, and I would really thank my organizing team, Professor David Kulpillai, Rajesh Patak sir, Swapnil, Faisal, the team of entire team of P6GA, and to all the participants who have wonderfully and actively contributed. We are looking forward for more such collaborations, and we hope that through these engaging sessions, the Indian contributions they keep up leveling up, and we do more for India. So thank you once again, all, and over to you, Patak sir, if any, or David sir, for any
No,
concluding
just
remarks in
wanted
relation.
to add to that word of thanks to the speakers, Mr. Puneet Jain, Dr. Anil Kumar, and Dr. Sai Prasad. And a big thank you to Professor Ganti as well for anchoring the entire session so well. Thank you all.